Hello, 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 and good morning. Welcome to math. Today, let's get right into it. Today, we are adding mixed numbers with unlike denominators. We've really come a long way since the beginning of the year when we were simply just deciding and figuring out what really a fraction is, right? And now we're doing all this stuff like adding mixed numbers with unlike denominators, adding a piece at a time, taking small steps through it. And we've really seen a lot of progress so far with these fifth grade mathematicians. It's been pretty awesome. Today, you're going to need the usual stuff, something to write on, something to write with, and our handy dandy multiplication table here behind me. And then our teaching points and our ICANs are down here. I can create equivalent fractions, and I can add mixed numbers with unlike denominators. So before we get into that, I do want to remind of one thing. This idea of the commutative property. Okay, and it's a concept that we've been talking about in math, and I've been saying it in math since I was a first grade teacher. Okay, so you've seen this word commutative property before. As a refresher on what it means, in here at the beginning, there's that word commute, right? When we talk about a commute, we talk about, getting to and from work or going from one place to another. It essentially means to move around, okay? And essentially our little mantra here is the addends change, but the sum stays the same. Meaning, if you have something like 10 plus 4 plus 3, it's all the same operation. You can have these addends in any order, and it's not going to change the sum. 10 plus 4 plus 3 is going to equal 17. 3 plus 10 plus 4 is still going to equal 17, because we haven't changed the value of anything. We've just moved stuff around. This is also true with fractions and mixed numbers. So let's look at a whole number example first. Where'd my eraser go? There you are. So in terms of a whole number example, if we had something like 25 plus 38 equals something, okay? Using this commutative property, we can deduce that, well, first, using our place value knowledge, we can separate this 25 out and this 38 into expanded form. So we can rewrite our problem below of 20 plus 5, there's our expanded form there, plus 30 plus 8. Okay, there's our expanded form there. We haven't changed anything, we've just expanded it out. Now, we can use our commutative property to reorganize our addends here into a way that can make kind of a little bit more sense and can help us add a little bit easier. Okay, so what we're going to do with this one is we're going to put all of our tens, our multiples of 10, kind of in the same spot, and all of our multiples of 1 in another spot. So we can rewrite this again to 20 plus 30 plus 5 plus 8. Okay, again, we haven't changed anything about the value of this problem. We're just rewriting it in a different order. And because of our commutative property, we can do that. Now, let's add 20 plus 30 to get 50. And let's add 5 plus 8 to get 13. And now, we could even go a step further and go 50 plus 10. I'm writing this out in a very, very long and drawn out way because I want you to see it. 50 plus 10 plus 3, or 60 plus 3, which equals 63. Okay, is this the most efficient way to do this problem? Heck no, techno. There's a lot of steps just to do 25 plus 38. But it's showing us that using this commutative property, we can rearrange the addends of our addition problem. And likewise, you can do it with multiplication too. It's kind of cool that way. And figure out how to get and rearrange our addends to give us a little more straightforward way to add things up. This is going to come in handy when we're adding mixed numbers, because if you remember, all a mixed number is, and I'll even write the definition up here, mixed numbers, all a mixed number is a whole number plus a fraction. So it lives somewhere between whole numbers on a number line, between 2 and 3, for instance, or between 5 and 6, for instance. So if you have something like 2 2/3 plus 4 1/2, let's say, we can use that same commutative property to separate our whole numbers from our fractions. Because again, all this 2 2/3 is 2 plus 2/3. And then all our 4 1/2 is our 4 plus 1/2. Following so far? Okay. Now, using our commutative property, we can rearrange these addends without changing the value of our sum. So we can put our whole numbers together. So let's rearrange 2 plus 4. So there's our whole numbers. I'm going to put them in parentheses so we can see them a little easier. 2 plus 4. And then I'm going to put my fractions together. 2/3 plus 1/2. Okay, again, I'm not changing the value of anything. All I'm doing is rearranging the problem. If I had a bunch of puzzle pieces out, all I'm doing is putting them in a different place. I'm not adding or subtracting anything. Okay? Now, let's think about adding these. 2 plus 4, well, that's 6. Plus, now we've got our 2/3 plus our 1/2. Now we've got adding with unlike denominators. And we've been practicing that for a couple of lessons now. So let's practice it. Think about and look on our multiplication chart in the 2's and the 3's. What's our common denominator? It's going to be sixths. So it's going to be something in sixths. Let's rewrite our 2/3 in sixths. So 2/3 times some equivalent of 1 is going to equal some form of sixths, some number of sixths. Which equivalent of 1 are we using? 3 times what is 6? 3 times 2 is 6. So we're going to use 2 halves. And that shows us that 2/3 is equivalent to 4 sixths. So I'm actually going to erase and rewrite here. Rewrite 2/3 as 4 sixths. Now, 1/2. 1/2 equals how many sixths? 2 times 3 is 6. So I'm going to use 3/3. And now I can see here that 1/2 is equivalent to 3 sixths. So again, I'm going to erase and rewrite. So now we have 4 sixths plus 3 sixths. Keep your denominator the same, add your numerators. 4 plus 3 is 7. So we end up with 6 and 7 sixths. Is anybody noticing the one more step we have to do here? Take a look at our fraction. Remember, if the numerator is a greater value than the denominator, that means we've got more pieces than fit in one. If we have 7 sixths, if I were to draw this out, divide up into sixths, 1, 2, 3, 4, 5, 6 sixths, and I've got that 7th sixth left over. So what we want to do, if we can make another whole number, or in the case of some fractions, lots of whole numbers, if we can make another whole number, we want to do it. Okay? So our 6 and 7 sixths oops, our 6 and 7/6, we're going to add this whole number to the rest of our whole numbers. So 6 plus 1 is 7. And then what fraction do we have left over? We have 1/6 remaining. So we get a final answer of 7 and 1/6. A lot of steps. And that's okay. The more and more comfortable we get with this, the more steps can take place in your head, right? If we look up here, do we have to spell all of these out? We certainly can. It's very clear that way, okay? We want to be accurate first. So if being the most clear helps us be the most accurate, then we need to do it, all right? But if you already look at a problem like 2 2/3 plus 4 1/2 and go, okay, well, I know that's going to be 6 plus something. You could skip right there. You could skip to this step down here. If in your head you can look at it and go, okay, well, 2 plus 4 is 6, and then 2/3 plus 1/2 is the thing that I have to solve on paper or solve on a whiteboard, you can go straight there, okay? You don't need to write everything out, but I encourage you to do it if it helps you stay organized. Let's try one more, and I'll show you what I mean. So let's take 3 and 3/5 plus 10. 10. Oh, let's go 10 and 1/10 to be cheeky here. So first thing we're going to do, separate those mixed numbers out. 3 plus 10. So here's what the step that I'm doing in my head. I'm separating it out into 3 plus 10 plus 3/5 plus 1/10. Because of that commutative property, I'm allowed to do that. Okay? It's mathematically accurate to do that. So I can skip straight to 13 plus, and then here's where we have our 3/5 plus 1/10. Now let's think about, sorry, this plus sign's a little crooked. I'm trying not to show you my back all the time and like kind of stay cheating out like I was on stage, but then that causes me to like write all slanty ways. So we have 13 plus 3/5 plus 1/10. Now let's think about, here's our 5s, here's our 10s. What's our common denominator here? I can see in the 5s row, there's already a 10 there. So I know my 1/10 can just stay as it is, because 5/5 will expand out as an equivalent into tenths. But how do I do that? 3/5 times some equivalent of 1 equals some tenths. And I had a great strategy from our small group where we were, even before we put that in, we were reminding ourselves by putting in our 1 box, we were reminding ourselves that that's an equivalent of 1. So the numerator and the denominator have to be the same here. So 5 times what is 10? 5 times 2 is 10. You can see it right there. 5 times 2. That's where they meet. 2 times 5 is 10. And it's actually cool on our multiplication table. Look, it's like an area model. There's 10 numbers right here. What? I know. It's incredible. Okay. 3/5 times what equals 10? 2. And then because it's an equivalent of 1, we're going to make it 2 halves. So 3 times 2, and 3/5 is equivalent to 6 tenths. So rather than rewrite the whole thing, I'm going to erase and rewrite. Erase and replace. Ooh, I like that. Erase and replace. Did I make that up? Am I the first person? Am I the first math teacher to ever say erase and replace? I hope so. Again, remember, this is all about like internet clout, right? So I'm like trying to get famous on some stuff here. So maybe I can copyright erase and replace. Sorry, you want me to move on? Okay, great. 13 plus 6 tenths plus 1/10. So keep your denominator the same. Add your numerators. 6/10 plus 1/10 equals 7/10. And because our numerator is smaller than our denominator, we're split into tenths. We only have 7 of those tenths, so that is a proper fraction. That is less than 1. So we can just combine them to make our mixed number of 13 and 7/10 as our final answer. I'm going to rewrite it back up here with the original problem. So then we end up with 3 3/5 plus 10 1/10 equals 13 7/10. Okay. So remember, separate out your whole numbers from your fractions. If you only have a mixed number with one of them, that's fine. Like, let's say this wasn't 10 1/10, this was just 1/10, right? All we do is we still separate out our whole numbers, but we only have one of them. So we'd end up with 3 7/10. We should take 10 away at every step. Separate out your whole numbers from your fractions, then worry about finding that common denominator and adding, then put it all back together. Thanks to our friend, the commutative property, we are allowed to do that as mathematicians. It is very, very useful and very, very flexible for mathematicians. Let's try one on the digital whiteboard before we go. Here's your problem. 3 4/5 plus 1 3/10. Oh, look at that. Same fractions. We just worked with fifths and tenths, so we should be pretty quick at remembering what our common denominator is. Your common denominator. I got mouth mush there for a second. It's still in tenths. So, again, separate out your whole numbers. So 3 plus 1. And then 4/5 plus 3/10. 3 plus 1 is 4. And then 4/5 plus 8/10. Here's another area where if you were feeling so inclined and you're feeling up to the shortcut, you could just, rather than putting 4/5 plus 3/10 and rewriting it here, you could take this step and just add them straight away. But I find it helpful to rewrite my fractions so I know what I'm dealing with here. And I can even put them in parentheses so I can see them a little clearer and know that it's going to be 4 plus whatever's in those parentheses. Okay, so 3/10 can stay the same. Remember, if we're dealing with fifths and tenths, 10 is a multiple of 5. 5 is a factor of 10. So we can just do 4/5 times our equivalent of 1 equals some tenths. Five times 2 is 10, so we're going to use 2 halves. So I know that 4/5 is equivalent to 8/10, because 4 times 2 is 8. So let me erase and replace here. I'm going to erase my 4/5, replace it with 8/10. Denominators stay the same, numerators get added. So what do we end up with? I'm going to scoot this up just slightly. You might lose the top of the original problem, but I do want some more space for us here. We end up with 4 plus 8 plus 3 is 11/10. I've been using my arrows in red, so I'm going to rewrite them in red just to be a little bit more specific here. Okay? So if you're feeling up to the shortcut, you could have skipped this step and gone straight to here. But in the interest of clarity, we can draw it out. Now, can I do anything with 11 tenths? Can I make a whole number with 11 tenths? Sure I can. I can make a whole 1, right? Because 10 tenths equals 1. So I end up with 11 tenths equals 10 tenths, or 1, plus how many tenths left over? 10 plus what is 11? 1/10. Exactly. So I can add this whole number to my 4, because now it's out of the fractions group and it's into the whole numbers group. So then I end up with 4 plus 1 is, and I'm going to write it back in the original problem, 4 plus 1 is 5. And then I have my 1/10 left over, giving me 5 and 1/10. So our final answer is, our final equation looks like 3 4/5 plus 1 3/10 equals 5 and 1/10. It's kind of behind my face. Let me move my face out of the way. There you go. There it is. 5 and 1/10. All right, everybody. So remember, the name of the game today is, just like it says at the top, separate. Separate your whole numbers from your fractions. Then add the whole numbers together, add your fractions together, find those common denominators, and then if you have an improper fraction at the end, you can regroup it. I will accept numbers, or I will accept answers with improper fractions as long as they're accurate, but do be aware that when you have more pieces than fit in a whole one, you can regroup them to our whole numbers. All right, everybody, thank you for tuning in. Small group is going to start in about 5 minutes or so. Do feel free. Thank you to those of you. I've been noticing how many views the replays are getting, and they've been getting a few views. So thank you to those of you that are replaying the video. And if you're unclear about something, or you're like, I knew Mr. Taco said that in the video, but I can't remember what it is, go back and watch that video. That's the cool thing about YouTube, is that they'll live here indefinitely until the internet explodes on itself in a billion years or whatever it is. So do take advantage of that idea that you can replay any lesson that we've had on YouTube. It's a really cool feature, something that we actually can't do in the classroom. So take advantage of it while we're in distance learning. Okay, everybody, thank you for tuning in. Hope to see you at small group if you have questions. If you don't have questions and just want to work on the exit ticket, then go ahead and do that. And then we will see you back here for science at 1:15. Don't forget to collect your leaves. You'll need some leaves for science today. Thank you, and have a wonderful rest of the morning.